Hi there, welcome to Lesson 6 in Unit 1A on polynomial functions. Today we are going to look at data given in a context or a story problem and model this and be able to come up with equations, specifically systems of equations that make this data up and generate a function that will match this data, okay? So today we are going to be successful if you can create a system of equations, meaning two equations using given data, and you can solve the system of equations using the substitution and or elimination methods, as well as solving by graphing, as well as running a regression. These are topics that I will talk about. So first of all, I do want to talk about what a periodic function is, and the data that we're going to be looking at today will not be periodic at all in nature. A periodic function has a repetitive pattern which oscillates between the same values over consecutive intervals of equal length. So, for example, trigonometric functions would be periodic. So sine of x, cosine of x, because these values repeat over a given interval. So you can see here for sine of x we get 0, 1, 0, negative 1, 0, 1, 0, negative 1. They repeat. Polynomial functions are what we call non-periodic because they do not have this repetitive pattern. So we're going to go ahead and we're going to construct, given data, a system of equations, and then we're going to explore different methods of solving. And prior to AP Precalculus, you've probably encountered these. There are the main two. There is substitution and there is elimination. Now the substitution method, what you do is you solve for one variable in terms of the other variable, and then you substitute that back in to solve for that variable. Once you have one variable solved, you can plug that value in and solve for the second. Elimination is my personal favorite because I stack my equations and then I either add or subtract them to cancel out one variable. And so again, I solve for one variable and then I plug that back in order to solve for the other one. Now, there is another method which we will go ahead and explore, and that is with Desmos. So if you have a graphing calculator, you can use a TI Inspire or you can use Desmos. You'll want to go ahead and open up that graphing calculator, and you can also solve by graphing. And I can just enter, two equations here: y equals x plus 2, y equals x minus, I won't do x, I gotta change the slope. Let's do a constant function, and let's make it 6. So you can find where two functions are equal if you just click their intersection, right? And so this point where they touch, that would be our solution. Okay? Solving for 3. What if I have 3 equations? Well, you're going to put all of them into the same form. Choose 2 equations to eliminate a variable. Or if you can't, you have to multiply one or both equations by values that create opposite-like terms. And then you're going to choose another 2, multiply one or both of those, that will be able to allow you to cancel, and then you take those 2 equations to make an elimination system, okay? So we'll cover all this when we get to it, okay? But let's go ahead and jump into an example. So here is our first example. Okay, and we say here, the balance in Amani's savings account on the 5th day of the month was t equals 5, was $55. On the 11th month, t equals 11, the balance was $37. The balance in Amani's account can be modeled by the function b, where b of t equals a times t plus b, where b of t is the balance in the account in dollars, and t is the day in the particular month. Now, sometimes they give you these information in these stories without a data table. Sometimes they do give you a data table. So I like to make the data table, and it helps me to plug in these values. So what they told us here was there's a savings account, and on the 5th month, Amani has $55. So there's your first data set, 555, right? That could be like an ordered pair, 5, 55. On the 11th month, month 11, the balance was $37, okay? So it looks like she's losing money in her account. Okay, so they say use the given data to write 2 equations that can be used to find the values of the constants a and b. And so here's the function that we're going to use. B of t equals at plus b. So b of t equals a times t plus b. And so all you're going to do is just plug in this information. It's pretty easy. So I'm going to plug in, okay, 55 is equal to a times 5 plus b. Now, you may be asking yourself, hey, can I just go ahead and multiply? Is this 5a plus b? Sure, but you don't have to. You can just plug it in. 37 equals a times 11 plus b. And then b here they say, find the values of the constants a and b. And so I have two equations here. And what I'm going to go ahead and do is I'm going to solve for one variable. So let me go ahead and rewrite this. 55 is equal to 5a plus b. And I'm just going to solve for b. I'm going to subtract 5a on each side, minus 5a. And we get b is equal to 55 minus 5a. So I've solved for one variable, and what I'm going to do is I'm now going to plug this into my second function. So notice b is 55 minus 5a. Well, here's b. Okay, so here's my other equation. 37 is equal to 11a plus b. But instead of b, I'm going to go ahead and I'm going to substitute, right? So that's why this is called substitution. Substitution. Okay, so I get 55 minus 5a here equals 37. And I'm going to combine like terms. Okay, so we get 37 equals 11a minus 5a plus 55. We can combine those to give us 6a. And I can also subtract 55 on each side. Okay, that cancels. And what we get over here is negative. Is that 18? I think that is. Okay, and so we can go ahead and divide both of these by 6a. Divide by 6. So a equals negative 3. Okay, there's my first variable. And now that I know a equals negative 3, what I'm going to do with this is I'm going to plug it back into this equation. b is equal to 55 minus 5a. Well, I know that a is negative 3 now. So this gives me 55 plus 15, which gives us 60. So b is equal to 60. And I like to just go ahead and put them next to each other so it's clear that that's the solution. Oh, and it's not 60, it's 70. 70. 55 plus 15 is 70. Okay, there you go. Now, how else could I have went ahead and solved this? I want to show you solving by graphing on a calculator here. I'm going to enter these two equations. 55 equals 5a plus b, and I have 37 equals 11a plus b. Now you'll notice it's not graphing it because Desmos does not like these variables. They like the variables x and y. And so what I'm going to do is I'm going to take out a, I'll put x, and I'm going to take out b and I'll put y. So a is x and b is y. So if you have graphing technology, which on the AP Precalculus exam, this is a graphing calculator active question, I can graph. I can graph these, and then I can find where they touch. Here we go. And I can click on that intersection and check it out. There's my solution. X equals negative 3, y equals 70. So graphing is definitely a technique also that is helpful. Okay, here is a practice question. Go ahead, I want you to pause the video. I want you to try to solve this one. Okay, in this one, here is the given data for Garrett growing a bean plant. And they say day 6, the plant is 13, I think, centimeters tall. And on day 15, it's 19 centimeters. So here's your two equations, and you can solve this. Again, this is with substitution, what I did here. This is substitution. So if you use substitution, here's what the two equations would look like. You solve for b by moving the 6a over, and plug that into our second equation. So 19 is equal to 15a plus my equation from up here, which is 13 minus 6a. Solve, and you end up getting 9a equals 6. So a is equal to 6 over 9, which is 2/3. You plug that back into your equation for b, and you get b is equal to 13 minus 6 times 2/3, which is 4. And so you get 9 as a solution. Now, I did want to go ahead and I want to show you elimination. So if you have some room, I would go ahead and jot this down. You can use this on your next practice one. But elimination is a really, really good tool for systems of equations as well. And I tend to like it better. So I'm just writing my two equations here, and I'm making some purposeful decisions about who I list on top and who I list on bottom. Now, elimination only works if you have variables that have the same coefficient or opposite coefficients, because you can add or subtract these two equations. And so what I'm going to do is I'm going to subtract these two equations, because then these b's cancel. B minus b cancels. And what I get is I get 6, and then over here I get 9a. Oh my gosh, look at that. I got that equation so easy. All I had to do was just subtract. And then I can solve for a. We get 6/9 is equal to a. And then once you do that, I can pick an equation and I just plug it back in. So I can take this and I can choose either equation. I'll go ahead and choose 13 is equal to 6 times a, which again is now 6/9. And I'll put this in orange so you can see it, 6/9. And plus b. Okay, and so we get what? 36 divided by 9 is 4. And you can see that b is equal to 9. Okay, that's elimination. I don't know if you think that's easier than substitution. It looks like a little bit quicker. But again, it only works if you have a variable in your system that have the same coefficient or opposite coefficients. All right. Next, practice one. Please go ahead, pause me here, and I want you to solve this equation. All right, here's your two equations based upon the given data. This is Jennifer holding her breath, and her training. On the second day, she can hold her breath for 31 seconds. On the fifth day, she can hold it for 43 seconds. So here's your two equations. Again, you don't have to simplify, but once you do, in order to solve, you get this system. And again, you could solve this via substitution. The method that I used here was, again, elimination. I used elimination. And so I eliminated by subtracting, and so I got 3a equals 12, divided by 3, you get 4. Plug that back into my bottom equation, and I get 31 equals 8 plus b, subtract 8 on each side, and you get b is equal to 23. So there's a and b. Again, you could have solved this via graphing, so I can go ahead, and again, I can graph this. So 43 is equal to 5x plus y, and 31 is equal to, I think it was 2x plus y, and we can find their intersection. They touch right here, 4, 23. So solving with graphing, pretty simple. Okay, that's going to do it for this video, specifically on modeling a non-periodic context for linear equations, if it's modeled by a linear equation. In the next video, I will talk about what do I do if I have a quadratic system of equations. Okay, like the video, subscribe. I'll catch you in the next one.